In this lesson of slope-intercept form, in 8.5, a linear equation of the form y is equal to mx plus b is said to be in slope-intercept form. The slope is m and the y-intercept is b. So in algebra, you'll see it is y is equal to mx plus b. The m is a slope, the b is a y-intercept. And in numbers, we give an example, y is equal to 2x plus 3. The 2 is, m is equal to 2 because that's the slope. And 3 is the y-intercept because that's where it crosses the y-axis. So in this example, our slope is going to be 5. And our y-intercept is going to be negative 12. Now, you'll notice in B, we're going to need to put it in slope-intercept form. Dividing each side by negative 3. Now we changed this to a slope-intercept form. Our slope will now be positive 8/3. Our y-intercept would be negative 2/3. So now we're going to graph A. We're going to take where our where our y-intercept is and graph it. That's where it crosses the y-intercept, and our slope in A is 5. So that means our rise is going to be a 5. And our run is going to be a 1. So from this point, I'm going to rise 5. 1, 2, 3, 4, 5. Run 1. From this point, we can continue on so that we can show that there's the line for this. 1, 2, 3, 4, 5. Rise 5 and run 1. So when you connect that line, it's going to be an endless line. So you in your notes need to put arrows at the end of each one of these. So this is what your graph should look like for A. Now let's graph B. So in our graph for B, our y-intercept was negative 2/3, so I plotted it here. Now, the slope is 8/3, and that's positive. So from here, we are going to rise 8 and run 3. So here's 1, 2, 3, 4, 5, 6, 7, 8. Run 3. 1, 2, 3. Didn't go quite where I wanted it to go. Might just have to make it work, but apparently I am, because it needs to go right here on the 2/3 mark, so right below it. So again, from here you can rise 8. 1, 2, 3, 4, 5, 6, 7, 8, and run 3. 1, 2, 3. Draw your line and arrows at the end of each. So this graph right here is a graph of y-intercept of negative 2/3 with a slope of 8/3. Okay, now in example 2, we've been given a slope-intercept form. I am going to pause the video and we'll come back and check our work. So here's what your graphing of this slope function would look like. In example 3, Samuel has $42 in his bank account each week. Samuel has $42 in his bank account, and each week he deposits another $3. Write an equation that models his account balance after X weeks. Use an equation to determine when he will have $120. Again, using the slope-intercept form, set up an equation to represent this example. So we're going to set this up in slope-intercept form, where y is the amount. We already know that he deposits $3 each week, and x is going to represent our weeks, because that's what we need to determine is how many weeks it'll take him to earn a certain amount. He already has $42 in the account. So we've been given that he wants to earn $120. That's going to be our y. Then he'll be depositing $3 each week. He's already got $42 in there. So we're going to need to solve for x. We need to solve for how many weeks it's going to take him to earn the $120. 26 is going to be equal to the x weeks. Now, in slopes of parallel and perpendicular lines, two non-vertical parallel lines have the same slope. For example, parallel lines A and B both have a slope of 2. So you indicate that as A is parallel to B. If you were to take any point on A to determine what the slope is, we rose 2, ran 1. We rose 2, we ran 1. This is a positive slope of 2. And here on our line B, we can take any point on the line. It's easy to determine. And we can rise 2, 1, 2, run 1, rise 2, run 1. These two lines are parallel, and they have the same slope. So they are parallel, slopes of parallel. Now in the perpendicular lines, notice it's like an intersection. It's indicated A is perpendicular to B. I'm thinking it should be A is perpendicular to C on this one. Now in this example, A is perpendicular to C, and you see the right angle there. So any line on this, let's look at A and let's look at our slope of A. Let's pick an easy point. Here's one right here. So if I put a point right there, so I had a little technical difficulty on here, but in A, I plotted an easy point to determine what my slope was. So here I have, from this point I rose 2, ran 1, and got to that point. So here, and notice that it is a positive slope, hence positive 2. In our line C, I can plot a point here. I rose a positive 1, and I'm going to run a negative 2. Here, on our perpendicular lines, slopes, they have slopes that are negative reciprocals of each other. So since this slope in A is a positive 2, these lines are perpendicular, so line C will be a negative 1/2. In our last example, example 4, we're to find the slope of the line that has the given relationship of the line with the equations 3y minus x. So on this, we're going to determine what our slope is, and then what the parallel slope is, and what the perpendicular slope is. So the first thing we're going to need to do is put it in slope-intercept form. So we have 3y minus x is equal to 6. 3y, we're going to add x to each side. 3y is equal to x plus 6. Next, we're going to divide each side by 3. Y is going to equal to 1/3 x plus 2. Now, in this example, we can determine now that the slope, our slope is 1/3. So in order to determine what is parallel to that line, the parallel slope to the line would be 1/3. And in B, if you're asked to find what is perpendicular, remember it is going to be its negative reciprocal. So the reciprocal of 1/3 is 3/1, or 3, and it will be negative.